Hi, Honors Algebra. We are now finally on 8.1, day 2. We are starting with problem 2D on your notes, so make sure you're following along, taking notes when you're watching the video. So, we are going to continue completing the square, solving a quadratic equation by completing the square. However, if you look, problem D is a little different than the first three because the leading coefficient of problems A, B, and C up here, all of the leading coefficients that had the square term were 1. So our A value was 1 every single time. In this example, our leading coefficient with the square term is 2. And we have it in standard form, so you do have to make sure that your equation is in standard form, ax squared plus bx plus c equals 0. We have to get rid of this 2. We have to make this coefficient 1 in order to complete the square and make it a perfect square trinomial. So to get rid of this coefficient of 2, we're going to have to divide both sides of our equation by 2. And remember that these are separate terms. So if I divide each separate term by 2, I'm going to end up with p squared minus 2p minus 1/2 equals 0 divided by anything is 0. Okay? Now, once we have our equation in standard form with a leading coefficient of 1, now we can begin to complete the square. So you have to make sure that this is in standard form first before you complete the square with our coefficient of 1. So now what I'm going to do is I'm going to rewrite this equation just like it did the previous ones, and I'm going to get rid of that minus 1/2 by adding it to both sides, and I'm going to save room because I know I'm going to have to complete that square to make that a perfect square trinomial. So if I look here, my A term is 1, my B term is -2, and I need to find what that C term is. So we're going to take our B term, which is -2, and we're going to divide by 2, and we're going to square that. So -2 divided by 2 is -1, and -1 squared is 1. So I'm going to add 1 to both sides. And now I have a perfect square trinomial. So I'm going to rewrite this in factored form. So by now, hopefully you could see that that's p minus 1 times p minus 1, which is really p minus 1 quantity squared, equals 1/2 plus 1, common denominator, would be 2. So 1/2 plus 2/2 is 3/2. Okay, and then I'm going to go ahead and use the square root method, and I'm going to solve for p, get p by itself. So I have to get rid of that square by square rooting both sides. And again, when you square root both sides, the square root cancel out. I now have p minus 1 equals plus and minus the square root of 3 over the square root of 2. Because if I rewrite those separately, that's what I get. However, I cannot have a radical in the denominator. So I'm going to have to rationalize that by multiplying top and bottom by root 2. So I really get p minus 1 equals plus and minus. Root 3 times root 2 is root 6, and root 2 times root 2 is just 2. Okay? Root 6 cannot be simplified other than 2 times 3, so we're good. Now I'm going to get p by itself and isolate that by adding 1 to both sides. And when I do that, I'm going to get p equals 1 plus and minus root 6 over 2. Okay. Now again, I could write those separately as 1 plus square root 6 over 2, and p equals 1 minus the square root 6 over 2. But I'm going to leave it like that so we can move on. And that's the answer to problem 2D. Okay, so what we're going to do now for problem E, we're going to do the same thing, except this looks kind of mixed up, like we have some work to do. And so does F, we have simplifying to do. So basically this day is about, if you need to simplify, simplify first. So if we simplify this by distributing, we're going to get 2x squared plus 9x equals -4. Now, we do have a coefficient of something other than 1, so we do have to make sure we have this in standard form first. So we're going to have to add this 4 to both sides, and when I do that, setting it equal to 0, now I can get rid of my coefficient of 2, and I'm going to do the same thing I did up there. That last problem was divide each side by 2. So when I divide each side by 2, I'm going to get x squared plus 9/2 x plus 2 equals 0. Okay? Now I'm ready to complete the square. Now I have to rewrite this in form, so I'm getting rid of my c value by subtracting it from both sides. So if I do that, I'm going to get x squared plus 9/2 x, and then I'm going to save some space for completing the square equals -2. And I know I'm going to have to add something here, so what we have to add we'll find out in a little bit. So I'm going to put some blanks there. So this is my a term, this is my b term, and we're trying to find our c term. Remember, our a term is 1 now, which is what we wanted. So we take our b term, divide it by 2, and square that. So 9/2 divided by 2 is the same as saying 9/2 times 1/2, which is really 9/4. Okay? But then we have to square that, which is 81/16. So we're really adding 81/16 here. And what we do to one side, we do the other. The nice thing about this, even though, again, it looks like, oh my God, what do I actually add? How do I factor this? Well, when you do this part here, just like up here, that actually gave you the factors. So we're actually going to have x times x, and then 9/4 and 9/4. So we know that in factored form, this is x plus 9/4 quantity squared equals, and then we have some work, -2 plus 81/16. If I go ahead and multiply top and bottom by 16ths, I'm going to get -32/16 plus 81/16, which leaves us, I believe, with, let's see, 49/16. So I have 49/16. So what I'm going to do is I'm going to rewrite this up here and carry forward. So we have x plus 9/4 quantity squared equals 49/16. And from here, I'm going to go ahead and use the square root method, which says, okay, I'm now going to square root both sides. And as soon as I do that, again, those cancel out, and I'm left with x plus 9/4 equals plus and minus the square root of 49/16. Well, these both work out nicely because the square root of 49 is 7 and the square root of 16 is 4. So now I have this, and I want to solve for x, so I'm going to subtract 9/4 from both sides. And when I subtract 9/4 from both sides, something even nicer happens. I don't have any radicals, but I do have like terms. So I could take 7/4 minus 9/4 and find and simplify that, which is equal to -2/4, which reduces to -1/2. So x equals -1/2 is one answer. And then I also have x equals -7/4 minus 9/4, which, combining the signs, you have -16/4, which is -4. So x equals -4. So there are my two solutions for problem E. Sorry we went into the F a little. Let me try and see if I can eliminate some of the work. I think what I'm going to do is, since you have this on video, I'm going to erase it, and you could go back and visit anytime you want. I'm going to erase this part so for video, when you do F, it won't be confusing. So for part F, problem F, we have some simplifying to do. Okay, we can't just leave it like this. This is not factored form because we have some random number out there. So we're going to go ahead and simplify by FOILing. So we're going to get x squared plus 3x plus 2 equals 11. okay? Now, if you look here, if we go ahead and we already have our number in standard form, but we have to get this on the other side. So I have x squared plus 3x minus 9 equals 0, okay? So if you do that now, and you know, I guess we could have skipped this step. We could have just subtracted 2 from both sides and get 9, but you know, if this coefficient were something other than 1, we definitely would have to bring this over anyway. So you should get into the habit of doing that. So you're putting it in natural standard form, just in case that coefficient was something other than 1. But now we're going to complete the square. So if we add 9 to both sides, we're going to get x squared plus 3x plus, we're going to leave that blank, equals 9 plus some blank number. This is our A, this is our B, we're looking for our C. So we're going to take 3, our B term, divide it by 2 and square it, which is 9/4. So 9/4 is our winner. We're going to add 9/4 to both sides. And again, if you're like, how is that a perfect square trinomial?